Hello guys, I'm back and I'll be discussing now a method of solving quadratic equations, and by this time I'll be discussing the completing the square method. No, as we know, we were able to present on how to solve quadratic equation by factoring and by extracting the square roots. Now we are on the third method, which is the completing the square method. So when to use the completing the square method? So if you write your equation to follow a standard form, no? What is the standard form? That is the ax squared plus bx plus c equal to 0. So this is applicable if the first degree term is present. So dapat na ani. So the third term, so dili ka importante. No? So what is important is there is a first degree term and a second degree term. Okay? Now this is how to do that. To solve by completing the square method, no? So let x squared plus kx form to appear in the equation. So any constant, if it is present, it will be placed on the right side of the equation. So you can have it as a right-in member of the equation. Now for x squared plus kx, no? So you need to insert a term. No, the third term in the space will be provided, and the third term is equal to half of the coefficient of the first degree term, or your key here is the coefficient of x. Now, so the term to be added is half of which, and then you can take the square of that to form x squared plus kx plus the square of k over 2, which is now a perfect square trinomial. Okay? So the equation is neutralized. Now, since you are adding a term on one side of the equation, so it can be neutralized by adding the same term on the right end of the equation. So after providing the k over 2, the square of k over 2, then you can also write that as a binomial square, because this expression karon, the x squared plus kx plus k over 2 square, no, is already a perfect square trinomial, which can now be written as a binomial square, and the right end member will also be combined. Okay, then you can extract the square roots on both sides, and you can proceed finding the roots and then the solution set. Okay, so before presenting an example of this kind of, or this method of solving, so let us present now this one as a way of recalling now what is a perfect square trinomial. Now, if we have a trinomial, this one, a squared plus 2ab plus b squared. So this is a PST, a perfect square trinomial. So if this is a perfect square trinomial, we can also write that as a binomial square, where the first term of your binomial is just the square root of your first term here. So if that's a squared, I can put here a. If this is b squared from the last term, then I can put there also b. To really find out that this is a perfect square trinomial, the product of a and b will be doubled, and that is your middle term. Then that is a perfect square trinomial. Now, if there is x squared plus kx with an unknown third term, no, wherein we need to have a perfect square trinomial also, similar to the first line, then we just let our first term, the a squared and the x squared, to be equal. Okay, so actually I want to show why is it that I'll be adding a k over 2, or a square of k over 2 being my third term. So if my a squared is your x squared, so it means that there are square roots. So it is a is equal to x. Now I'm after for b. No? So kaning b, or your third term, because if these two pareho na sila, so I also need to have my third term, which is b. Okay, so how to get my b? My b is found at the kining a term na 2ab. Okay, so if my 2ab is equal to kx, are you following? If 2ab is equal to kx here, and I'll be solving for b. Okay? So, 2ab is equal to kx, and in finding what is b, so that means I have to divide with 2a both sides. Okay, so if I have to divide with 2a both sides, then this will give you b here. So there, we have k, but my x is equal to, where is my x? Is equal to a. So if that is replaced with a, then a is eliminated, and I can have k over 2. So, which means your third term must be k over 2, but it should be in square. Dire? So, it should be k over 2 squared. No? So, napakita na to nga we really need to have the half of the constant coefficient of the first degree term in order to arrive with a perfect square trinomial when it takes a form like that. Okay? So that is the form now where we have the perfect square trinomial, and then we can also write that as a binomial square because this is your a squared, so this is your a, and this is your b squared, so this is your b. So a plus b, the whole quantity can now be raised to power 2, being taken from perfect square trinomial. Now, to solve a particular problem, no? So, we are guided with the steps, no, previously given to us, no? So, we can consider our equation to contain the x squared plus kx form. So, x squared plus, so this is your kx, no? The term that involves the first degree. So, this is not so important ang atong 7, but 7 as a constant can be placed on the right side, no? So, this is actually x squared, then plus kx form. No? Actually, your k is minus 6 on this case. Then, okay, so putting your equation to follow the x squared plus kx form. So, I have x squared minus 6x, then plus. Then, a space is provided for us to insert a term which can produce a perfect square trinomial for this. Minus 7 now becomes positive 7, and if I'm going to add a term here, then this can be neutralized by adding the same term on the right side. Okay, what is your k on this line? If this is x squared plus kx form, then my k is equal to minus 6. Correct? Your k is equal to a negative 6. So, if that is equal to negative 6, then ang ato sa daing k over 2 is equal to half of that, which is minus 3. So, with that, pwede na nako ma-insert dire. What is to be inserted? It is the k over 2 squared. So, it is the minus 3, then square. Are you following? So, x squared minus 6x plus minus 3 squared. So, you can insert the minus 3 squared, but since you are adding a term here, so you can neutralize by adding the same term on the right side, that is to maintain the equality relations between the two expressions. Okay? Now, this is a perfect square trinomial already. So, you can have a binomial square for this, same as this one. So, the square root of the first term and the square root of this, then you can have x minus 3 in your binomial to be put into square. While this one, they can be combined. 7 plus 9, this is 9. No? Now, we have a binomial square. Okay, so x minus 3, or the quantity x minus 3 squared is equal to the sum of this constant, which is equal to 16. So, if this is now the case, so pwede na ko, I can now proceed with extracting the square roots. Okay, so taking the square roots, so for constant, there is a plus and minus root for this. Okay, then we can further simplify. So, this is x minus 3, and this can be plus minus 4. Then you can proceed with roots by splitting the roots. You can bring the constant to the other side, so x is equal to 3 plus and minus 4. So, by splitting the roots, we have 3 plus 4, okay? And we have 3 minus 4. So, if you combine, we have pila? 7, and we have pila ni? This is negative 1. So, your solution set will contain both elements. We have the minus 1 and 7 as elements of your solution set. So, ingana lang. So, in number 2, no? So, this is, there is a little variation with this, no? Because in our given, no, this is not exactly following x squared plus kx because the leading coefficient here is not exactly 1, but there's a value 4. But if we are after to have the x squared plus kx form, then we can easily do that by just dividing with 4 every term. And you can bring the constant term on the other side. Okay? So, divide with 4. You're guided with the steps here, no? Just in case you will be confused, no? So, I just put the steps there. Then, there I can go with the solutions. Okay, so dividing with 4. And then you can put the constant term on the right side. So what is the effect? Okay, dividing with 4 is just the same as multiplying by 1/4. Okay? So, and put the constant to the right side. So, what is the effect? Okay. So, this can now be x squared. So, this is the first degree term. So, this is now 3. So, your k is equal to positive 3. And your 13 is also to be divided with 4. But it is not exactly divisible. So, you can express that in terms of fraction to be exact. Okay? So, minus 13 over 4. So, I'll be adding a term here. And then it should be neutralized with another term. The term to be added here is the k over 2 squared, or the square of the k over 2. By the way, what is your k? Your k is 3. The k over 2 is 3 halves, correct? Okay. So, my k is the coefficient of my first degree term, which is this one. So, there is 3. And we have half of that is 3 halves. So, this term will be inserted here, but it should be placed into square and be neutralized with also the same term being added at the left. Okay, so as an effect, we have 3 halves squared placed at left. Then it can also be placed at the right to maintain equality relationships. Okay, so what is your binomial square? After providing the third term, then this is now a perfect square trinomial which can be written as a binomial square. So you can have, mo ibutang dre, x plus the base lang, do not include the power. So it is x plus 3 halves. Then what is their sum? This is minus 13 over 4 plus pila, 9 over 4. Minus 13 and added with 9 is pila, negative 4 over 4, correct? Okay, here is your binomial square. So, x plus the 3 halves. Then, their sum is actually minus 1. Being in perfect square, so pwede na ka mag-extract with your square root. So, taking the square roots both sides. Okay. So, this one has a little problem because you are taking the square root of a negative number. And this is a square root of negative 1. Previously, we were able to encounter what is the square root of a negative number, or specifically, what is the square root of negative 1. The square root of negative 1 is equal to I, correct? Okay, so for this, we can have x plus the 3 halves, no? So, x plus 3 halves plus minus I, which is this one. And by splitting roots, we have, you can bring your constant to the right side, and this becomes minus 3 halves, no? Then I can split the plus and minus for I. So, we have the positive I, and we have the negative I in the second root. So, 3 halves is also good as 1.5 or negative 1.5 plus I, negative 1.5 minus I. So, there you have the solution set, and your solution set contains an imaginary roots. Okay? So, that is how to solve, no? Quadratic equations by method of completing the square. Okay, for now. So, thank you for following. And more videos to follow, no? Para you can also review your algebra. Okay, so I'll be sharing more because I am inspired to work now as also my way of support for the CA Club, no? So they are actually working on how to help their fellow civil engineering students, okay, of Cebu Institute of Technology University. So I'll be sharing more so to help also with our CE Club. Okay, so thank you for watching. And if you have time now, because this will be uploaded in YouTube, no? So just try to subscribe, no? And share with others. Thank you for watching.